Assalamualaikum, my name is Noalia binti Abdulrazak and my number metric is AA18011. So today I would like to talk about our topic for this project, which is slope stabilization using micropiles. So first and foremost, I would like to talk about the abstracts. This paper review focuses on the slope stabilization using micropiles. This paper review focuses on the determination fundamental design guidance for using micropiles for the in-situ stabilization of slope failure by performing slope stability analysis on case study using limit equilibrium software and finite element software. Let's move to the next chapter for this topic, which is literature review. There are many literature reviews that's been reviewed from us, but we only take important literature review for these videos. Slope stabilization micropiles using different methods. From just 2017, an elastoplastic technique used for the instant examination of a driven pile augmented at the ground with a micropile below axis resembling load is exhibited. The specimen is a stretch of a mandatory equation ways of Philus and Davis. The different technique used to obtain the pile displacement is reconstructed to take into pocket the irregularity in the pressure allocation at the joint load pile and micropile. Dick Vijay 2017. This paper points the investigation of different equilibrium method. Furthermore, finite element method in slope stabilization analysis based on critical works by various creators have been finished with respect of stability of slope. Different parameters and safety factor conditions utilized by them has been explored and examined precisely. Some mathematical instruments are too precise which can be utilized for investigation for slope in a specific condition. So let's move to the next chapter for this topic, which is introduction. Slope failure often results in extensive property damage and sometimes lost life. Improving the stability of both natural and man-made slope continues to be a fundamental problem in geotechnical engineering. Slope stability issues have been looked up all through history, and human nature has disturbed the insensitive adjustment of soil slopes. The expanding demand for the engineering caught and failed includes on a construction project has only need to comprehend logical techniques, investigative instruments, and stabilization techniques to take care of slope stability issues. A micropile is developed by a boring pole hole, placing reinforcement and grouping the gap. Micropiles construction is environmental friendly and installed in area with limited apparatus access like a hill and mountainous areas. The aim and objective for the study is to know the use of micropile stabilization of earth slope through the full-scale field of implementation at numerous sites and to observe several methods of slope stabilization using micropiles.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noah Atira Eliani binti Rani. So today I'm going to present about the methodology. So our methodology has two parts, which is evaluation of the capacity shear of single vertical micropile and evaluation of shear capacity of single incline micropile. So for the single vertical micropile, based on Matlock wrist and wedge, the characteristic shape of PY curve for the static and cyclic loading in clay adopted for the analysis. Secondly, the result can be obtained from the existing PY curve method and conventional beam and column equation. So for the theory of elasticity, so to develop expression for P as a function of Y, but the approach has been limited use because of the small strength of clay. Okay, lastly, the maximum shear force that the micropile can carry corresponds to the shear force applied at the elevation of the slit surface, which result is calculated in maximum bending force. This is the differential equation procedures, and this is the shear capacity of single vertical micropile. So for the evaluation of shear capacity in inclined micropiles, so firstly, the install of micropile in single incline micropiles has been also advocated. Secondly, the maximum lateral force for the inclined single micropile can be evaluated from the limit equilibrium method. Thirdly, based on Paulus and David, the maximum axial resistance can be assumed to develop in a pile inclined at approximately 301. Lastly, for the single incline micropile, the maximum lateral force can resist at the location of the critical slip surface.
Next, we are moving on to the result and discussion. My name is Nahusna binti Muslim. The application of design micropiles has been applied in K3 landslide in Qinghai, China. An existing embankment, slope, in Zabah Haqing roadway in China was adopted as an example. It had an approximate height of 30 meters with an inclination of 351. Then a gentle circular arc can appropriately represent the slip surface geometry. The appearance of the displaced mass can clearly indicate that the failure was rather in the form of material flow. Site conditions. There are two mainly geometrical units in the embankment slope, which are upper silty clay and lower siltstone. Scheme of stabilization. Two alternatives were considered for stabilization. One alternative was constructing anti-sliding piles, and the other one was the use of micropiles. The anti-sliding piles was rejected because it was not cost-effective, while the use of micropiles was selected because it is less expensive than the anti-sliding piles. Next, the design of micropiles. The diameter of micropile was 230 mm each. Each micropile was assumed to be reinforced with API 80 casing. The yield stress of the reinforcement was taken as 552 MPa. The alternate bending moment are 161.3 kN and 147.7 kN. In addition, the shear capacity of micropiles was 1078 kN. The micropile spacing required in row maximum is 1.65 meter. The plastic flow analysis was accomplished to check the potential solid flow between micropiles. Monitoring data. The K31 landslide was the first project in Qinghai, China, in which micropiles were used to create a permanent landslide stabilization system. 2 months after the construction, the measured displacement ceased and remained constant. These results indicate that the micropiles were effective in reducing slope movements. There are two main factors resulting in the large gap. The first one is the shear strength parameters of the embankment materials, and the second one is the field test result due to some uncertain factors, including difficulties maintaining and monitoring instrumentation, long testing periods, and change of testing conditions. In general, instrumentation data indicated that the micropile's performance was acceptable. In conclusion, the micropile was analyzed in two sections to compute displacement, shear force, and bending moment at each point. A step-by-step procedure has been proposed for the design of micropiles in earth-soil stabilization. An application of the design approach in a roadway embankment landslide in China was described, and monitoring data indicated that the slope movement had effectively ceased as a result of the slope stabilization measure, and micropile's performance was acceptable. That's all from us. Thank you.